Okay, today we're going to look at independent and dependent events. So let's say a sale advertises if you buy an item from the column on the left, you get a tote bag for free. So suppose you choose items at random. What is the probability of buying a beach towel? Yes. What's the probability of buying a beach towel? How many different outcomes do we have? Six. We could choose a t-shirt, jacket, hat.
Excuse me, teachers, may I have your attention, please? They are here working on the internet at this time, but the internet is currently down school-wide. Thank you.
So there are six possible outcomes. How many of them are favorable, which means buying a beach towel? There's only one way we could do that. So the probability of buying a beach towel is 1 out of 6. Now the next one, what's the probability that you receive a red tote bag? So how many different outcomes do we have? There are 3 different outcomes for the tote bag color we will get. How many of them are red? One of them. So the probability of buying a beach towel is 1 out of 6. The probability of receiving a red tote bag is 1 out of 3. Now it says, what's the product of the probabilities in exercise 1? So it means, what if I multiplied these together? What would that give me? 1/6 times 1/3. 1 over 18. Now it says to draw a tree diagram to find the probability that someone buys a beach towel and receives a red tote bag. So if we made our tree diagram, my first event, there are 6 possible outcomes. I could get a t-shirt, I could get a jacket, I could get a hat, I could get a beach towel, I could get a visor, or I could get a polo shirt. Then no matter which one I get, I'm either going to get a green, red, or white tote bag, right? Green, red, or white. Green, red, or white. Green, red, or white. I'm going to run out of room. Green, red, or white. And lastly, green, red, or white. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 different combinations, right? Which is what we found here when we just multiplied our 2 probabilities. So it's kind of like fundamental counting principle that we looked at before, where we can multiply to find the possible outcomes. The combined action of buying an item and receiving a free tote bag is a compound event. A compound event consists of 2 or more simple events. These events are independent events because the outcome of one event does not affect the other event. So if I have 2 independent events, we can find the probability of one and the other occurring by multiplying the probability of the first event by the probability of the second event. Okay, so we read here, it says, one letter tile is selected and the spinner is spun. What's the probability that they both will be a vowel? Oh no, here we go again. So first, how many events do I have? No, how many events? Not how many outcomes. How many events do we have? No.
2.
What are they?
Getting a vowel and spinning the wheel.
Choosing a letter tile is an event, and spinning the spinner is an event. So I have 2 events. So I have event tile and I have event spinner. So first, when we are looking at event tile, what do we want to happen? We want to know the probability that we get a vowel. So when I'm picking out a towel, sorry, when I'm picking out a tile, what's the probability that it is a vowel? Okay, well, how many possible outcomes are there? 1, 2, 3, 4, 5, 6. There are 7 possible outcomes when I choose a tile. So that means 7 is my denominator for my number of possible outcomes. Now the numerator is how many of them are favorable. So how many of them are vowels? 2 of them are vowels. E or A. So there are 2 possible vowels out of the 7 total. So the probability of choosing a vowel is 2 out of 7. Now we're going to spin the spinner. How many possible outcomes are there when I spin the spinner?
6.
There are 6 possible outcomes. Now I'm wanting to get a vowel again. So I want to know, what's the probability of choosing a vowel?
2.
There are 2 of them. So it's 2 out of 6. Will that reduce? Yes, 2 1/3. So the probability of choosing a vowel on a tile is 2 out of 7. The probability of spinning a vowel on that spinner is 1 out of 3. So to find the probability of both of these things happening, we can just multiply 2 over 7 times 1 over 3. 2 times 1 is 2. 7 times 3 is 21. Does that reduce? No. So the probability of both events giving a vowel is 2 out of 21. Okay, here's the next one. A spinner and a number cube are used in a game. The spinner has an equal chance of landing on one of 5 colors: red, yellow, blue, green, or purple. The faces of the cube are labeled 1 through 6. What's the probability of a player spinning blue and then rolling a 3 or 4? So first, how many events do I have?
2.
2. What are they?
The spinning spinner.
Spinner,
And the dice.
and then the number cube, the dice. Okay? So first, let's look at the spinner. What do we want to happen when we spin the spinner? We want to know, what's the probability of spinning blue? So on the spinner, what's the probability of spinning blue? Well, how many different outcomes are there?
5.
There are 5 different outcomes on that spinner: red, purple, blue, yellow, and green. How many of them are favorable? How many of them are blue?
1.
Only 1 is blue. So it's 1 out of 5 for the probability of spinning blue. Now the next thing I'm going to do, I'm going to roll the dice. What do I want to happen when I roll the dice? 3 or 4. So I want to know, what's the probability of 3 or 4? So how many different outcomes are there? 6. How many of them are favorable? 3 or 4. There are 2 favorable. Either I get a 3 or I get a 4. Either one of those works. Will this reduce? To 1/3. So now to find the probability of the spinner being blue and rolling a 3 or 4, we multiply these 2 probabilities. So we would do 1/5 times 1/3, which gives me 1 over 15. How many events do we have, Grant? 2 events. What are they?
Rolling 2 number cubes
So we've got to roll a number cube twice. So I'm going to call it roll 1 and roll 2. Okay, on roll 1, what do we want to happen?
2 and 4. 2 and 4. Roll a 2 over.
I didn't ask you. I'm not asking you.
A 2 or a 4.
Probability of getting a 2 or 4. So how many different outcomes are there?
2. I'm a
How many different outcomes?
6.
How many of them are favorable?
2.
Will that reduce
Yes.
to what?
1/3.
Okay. And then the probability of roll 2, what do we want to happen?
1 over 5.
We want a 5. So how many different outcomes are there?
6.
6. How many of them are favorable?
2. 1.
Only one that time, right? We want a 5. There's only one favorable outcome. Okay, so now what do we do?
Multiply.
So we're going to multiply 1/3 times the 6. What did you get?
1 over 18.
That's correct. So what if I looked at dependent events? So what's the difference between independent and dependent?
1%.
If somebody's independent, what does that mean? They can do stuff on their own, right? Whatever they do doesn't matter to somebody else. Okay, what does it mean if you're dependent?
You can't by yourself.
You need someone to help you. Okay, well, in probability, a dependent event means it depends on what happened during the first event. The second event could have different probability depending on what happens with the first one. So when we're looking at different events, we can still multiply, but we have to remember the second event could have some consequences from what happened in the first event. So right here's an example of a dependent event. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. I don't know how to say that name. Anybody know how to say that name? Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples were chosen. So, because Ignacio's going first, they can choose from anything in the basket. But because Terrence is going second, he can't pick what Ignacio picked, because there's going to be one less item in the basket. Right? He can't have the exact same thing that Ignacio had. So our 2 events are going to be Ignacio choosing a fruit and then Terrence choosing a fruit. So those are my 2 different events. So I'm going to name them I and T for Ignacio and Terrence. Now when Ignacio gets up there, what do I want to happen? I want for him to choose an apple. So I want to know the probability that Ignacio chooses an apple. Well, how many choices does he have? How many different outcomes are possible? Well, if he had 4 oranges, 7 bananas, and 5 apples, I would add those up.
16.
There are 16 possible outcomes for Ignacio. And how many of them are favorable? How many are of him choosing an apple?
5.
There are 5 ways he could choose an apple. There are 5 apples in the basket. So the probability that Ignacio chooses an apple is 5 out of 16. Now, Ignacio has chosen his apple. So now we go to Terrence. What do we want to happen for Terrence? We want him to choose an apple. So how many different outcomes are there?
16.
No.
15.
Yes. Because Ignacio has chosen his fruit already, there's going to be one less piece of fruit in the basket. So now there are only 15 possible outcomes. We assume that Ignacio picked an apple, because if he didn't, then it doesn't matter. We can't get what we want anyways. So assume Ignacio has went and he picked an apple. So now how many possible outcomes did Terrence have? He had 15. How many of them are apples? 4. Because we're assuming Ignacio picked one of them. Okay, so this is a dependent event. Do you see the difference? your denominator is going to change because the second event depends on what happened in the first one. So now to find the probability of both of these things happening, we multiply. I could cross reduce. 1 times 1 is 1, 4 times 3 is 12. So you should get 1/12 when you multiply those fractions. You can put it right in your calculator. It should do that multiplication and reduce it for you.